Assalamu alaikum. In the today's class, we are going to discuss soil classification. In the last class, we finished unified soil classification system, and today we are going to cover ASHTO classification system. So we are going to be discussing ASHTO classification system. So let's first look at what is ASHTO. ASHTO stands for American Association for State Highway and Transportation Officials. So this is the abbreviation. The first A, American Association for State Highway and Transportation Officials, AASHTO. This is called ASHTO. Okay, so this classification is primarily for highways. So this classification, when it is done, that is done for soil to be considered as a construction material in the pavements in highways. Okay, this classification was developed in 1929, and this classification is standardized by ASTM. ASTM designation is D3282, and also there is an ASHTO method for this, which is ASHTO method M145. So this normally gives us a rating for the soil to be used in the road construction. So in ASHTO, we divide the soil into 8 groups. So it starts with A1, A2, A3, A4, and it goes up to A8. So the first 3 groups, A1, A2, A3, these are the granular soils. Okay, so these are going to be the gravels and sands. So or simply I can call it granular soil. And from A4, A5, A6, A7 and A8, these are called what we can call it fine grained soil or silty clay soil. These are called silty clay soils. Okay, so the division among these two groups is passing number 200 sieve, which is 35%. So it says that if passing 200 is less than or equal to 35, this soil will be termed as granular soil. Granular soil. So what does it mean? Granular soil means this is gravel and sand. And if passing number 200 is more than 35%, then it is silt and clay. Silt, clay material. So what is silt and clay? So this silt, we know silt is M and clay is C. So gravel is G and sand is S. So if you remember, in unified soil classification system, the division was at 50%, but here in ASHTO this is little bit different. So let's look at the similarities and differences between these two methods. So let's first start with okay, on one side I'm going to write unified soil classification, USCS, and on the other I'm going to write the ASHTO classification. So we have two groups. So in case of unified classification, if you remember, passing number 200, if it is less than or equal to 50, so this is called coarse grained. coarse grained soil. And if you remember coarse grained soil, there was some symbols. It is actually gravel and sand, but if the gravels are well graded or they are poorly graded, then it is sand. It could be well graded sand which is poorly graded, or it could have uh, gravels with clay or gravels with silt. Okay, let's move this line maybe here. And then similarly we have SW, SP, well graded, poorly graded sands. Okay, no, let me correct it here. Let me rewrite it here. So it could be well graded gravels or poorly graded gravels, or gravels with clay and gravels with silt. And similarly, well graded sands, poorly graded sands, or sands are going to have some clay sands or silty sands. So these are basic 8 groups, but there are some borderline cases where there is a dual groups also, but we are not going into that. And for passing 200 sieve, if it is more than 50%, so this is called fine grained soil, fine grained material. And here there are less groups. It is either low plasticity clay or high plasticity clay, or low plasticity silt, ML or MH. So these are the 4 possible cases. Okay, now what happens in case of ASTRO? Passing number 200 is not 50, but it is 35. This is the first difference. So this is the difference, and these are called, instead of they calling coarse grained material, they call it granular material, but it's the same meaning, granular material. Okay, now here we are going to write it as the material will be called as A1, A2 and A3. First 3 groups are going to be granular materials, and if passing number 200 is more than 35%, then this is called silt or clay material, silt clay material or silty clay material. And here we have A4, A5, A6, A7 and A8. But this group A8, mostly the organic, highly organic soils, the soils which have very high composition, high percentage of organic material, highly organic clays, they are called peat, PEAT. So they are black color materials, and they have very strong smell, and they are very soft. If the load is applied, they are going to compress. So mostly those kind of materials are placed in this group A8, and we never use this in our construction. And if there is a area where the peat is encountered, we have to replace that soil. Anyway, this is the comparison between a unified classification system and ASTO classification system. Now let's look at the particle sizes. The particle sizes are also not same. There is some difference. So let's look at first the division. Okay, we have okay, on one side I'm going to write by ASTO, and on the other side I will write the unified classification system: gravel, sand, silt and clay. So here I'm going to write ASTO, and here on the right hand side I will write unified soil classification system. Okay, let's first look at unified classification system. We know in case of unified classification system, gravel's upper limit is 3-inch sieve, which is 75 millimeter, and the bottom is number 4 sieve. Number 4 sieve is 4.75 millimeter, and the division between sand and fines is number 200 sieve. so which is 0.075 millimeter. Now, in case of a unified soil classification system, how we are going to divide the silt and clay? We do not do the hydrometer analysis or sieve analysis. We are going to see if it is going to fall on or above or below a line on P chart. So we have to look at if it is silt, then we say plots below a line where on P chart. And what is P chart? This is plasticity chart. And what is clay? It plots on or above. Even if it is on the line, it will be called as clay. On or above a line on P chart. P chart. So if you remember, this is the P chart. So here is some dual area for dual classification, and if this material is going to be falling above this line, it will be called as clay, and if it is below this line, it will be called as silt. Horizontal axis is liquid limit, vertical axis is plasticity index. This is called P chart, plasticity chart. Now this is what you have studied in the previous lecture in unified soil classification system. Now let's look at what happens when it is AASHTO. So for AASHTO, this upper limit is same, 3 inch or 75 millimeter. Now the major difference is here. This is not number 4 sieve, but this is going to be number 10 sieve. Number 10. So number 10 sieve is 2 millimeter. So up to 2 millimeter, it is considered as gravel. So this is the big difference between unified and AASHTO. And for division between sand and fines, this is same, number 200 or 0.075 millimeter. This is same. But how we are going to differentiate between silt and clay? For that, we are only going to look at the plasticity index. Okay, in AASHTO, we only care for plasticity index. If plasticity index is less than or equal to 10, it will be considered as silt, and if plasticity index is more than 10, then it will be considered as clay. So this is the major difference between these two classification systems, and I have explained how the particle sizes are defined on this page. So you can go through your notes, and you will come to know about the particle sizes. So gravels, in case of AASHTO, it is passing number 3 inch sieve and retained on number 10 or 2 millimeter, and sand is passing number 10 or 2 millimeter sieve and retained on 200 or 75 millimeter. This is the same thing that we have seen earlier. And for in case of plasticity, if the plasticity index is 10 or less, it will be termed as silt. Okay, and if it is more than 11, it will be termed as clay. So that thing is here. Okay, so how we are going to classify? This classification process is easier than unified classification system. So here we have two charts. One is for granular materials, where the passing from number 200 sieve is less than 35, less than or equal to 35. So we are going to follow this chart, and on this chart we will start from this left case, and if all the conditions are satisfied, this is going to be our soil, and one of the condition is not satisfied, then we move to right, and we keep on moving till all the requirements are satisfied. When all the requirements are satisfied, we are going to stop, and we are going to say, okay, this is our problem. Okay, so this is for silt clay materials. For silt clay materials, the passing is more than 35%. We will see how to use this table when we do examples. Okay, one more thing here is the group index. Group index is calculated using this formula. Okay, so this is the formula for calculating group index. So here it's written F200, so you can consider this is actually F200, P200 is same. This is P200, and this is also P200. So this is a empirical equation or empirical formula. This tells us about the quality of material. So remember, the granular materials A1, A2 and A3, they always have a group index equal to 0. So in case of granular materials, group index will always be equal to 0. And in case of silt clay material, group index might be 0, but it might be more than 0. It might be non-zero number. So when you calculate GI value, if this GI value comes as negative, for example, you calculated and GI comes as minus 2, minus 2.3. So what we are going to do? We are going to make it 0. All the negative values will result into 0. And if we have a number with decimal places, then we are going to round off to the next integer. For example, if it is 3.4, it will become 3. Okay, if it is 3.3, 3.45, 3.48, it will become 3. But if GI is 3.5, 3.6, 3.7, then it is going to round off to 4. So you are going to get a number, integer. So for example, if I have a soil that has group A4 and its let's say group index is 26, and then I have another soil, the group is 4, but let's suppose its group index is 15, then the soil which has less group index is better than the other soil. So both cases it is A4. Okay, now if I have another soil, let's say A6, and here I say the group index is 18, then you don't have to see the group index. You will say, okay, A4 is better than A6. Okay, if the group is same, then you are going to look at the group index. So in this case, A4 with less group index is better than this soil. So if you have to pick from this soil, these two soils, if you have to pick from these two soil, this is going to be better. Okay, one more thing is that when we are dealing with there are two categories, two kind of soils, A26 and A27. When we are dealing with A26 and A27, only in these two cases we are going to use the second part of group index. This is the second half or second part of formula, second part of equation. Then we are going to use the second part of equation. Okay, so this was all about the background theory. Now let's do some examples, then you are going to understand how to use these tables. So let's start with our examples. Okay, let's do some examples here. This is the first example, and this we also did in our classification of unified classification system. We also did that example. So we are going to do the classification of the soil A. So remember, in AASHTO we have to look at what is passing number 200C. Is it greater than 35 or less than 35? So we have to look at where is CU number 200. So this is CU number 200. So look where it is going to touch the shape, the curve, S-shaped curve. So from here we should draw a horizontal line. So let's draw a horizontal line like this. So this is going to be, I guess this is 8%. So passing number 200C is 8%, which is definitely less than 35%. So it means it is a granular soil. So it will have the group either A1, A2 or A3. So straight away let's go to this table of granular materials where passing number 200 is less than 35. So if you look at, we need 3-4 things: passing from number 10 sieve, passing from number 40 sieve, passing from number 200 sieve, and we might need liquid limit and plasticity index. So if you remember in our in our previous class, we did the classification of the soil using using USCS, and we used over there liquid limit of 42 and plasticity index of 11. So this is what we are going to use here in this. this example. So it means we have to now find out passing number 10 sieve. So how we are going to do that? For passing number 10 sieve, where is number 10 sieve? This is number 10 sieve. And remember one more thing, number 10 sieve has an opening of 2 millimeter. You know, this is the division of sand and gravel in ashtray. Next is number 40 sieve. So number 40 sieve is 0.425 millimeter. So this is, and the last one is number 200, and we know what is number 200, 0.075 millimeter. So remember these three sieve and their opening. This is very important. Okay, now we are going to draw a line at number 10. We go down like this, and then from there we are going to go horizontal and see what is this value. So this value, so it is, I can say that this P10 is close to 50. It is less than 50. So let's me take it 48%. So when you solve, draw this line with the scale, so it is going to be more accurate. The more accurate is this one. So it is close to 48. So this is 48%. Let me clear this. Okay, next is P40. So for P40 we have to, this is P40, this number is already there. So you go down, touch this curve, and from there draw the line. So this is going to be, let's say this is P40 is 25%, and we know P200, this was P200, is 8%. So we got all these basic information that is needed, and now we can do the classification. So let me write here P10 is 48%, P40 is 25, P200 is 8, liquid limit is 42, and plasticity index is 11. So we have to start from the left column, and we are going to look at if all the requirements are satisfied. Now here it says that P10 is 50 maximum, means it cannot be more than 50. The maximum value is 50. Okay, what is our value? Our value P10 is 48. 48 is less than 50, it's okay. Next, P40, passing number 40 sieve. What is that? It is 30 maximum. So what is our value? 25. It's okay. Okay, the next one is P200. This is 15 maximum. Okay, 15 maximum. So what is our value? Our value is going to be 8. So this is okay. Now here, if you look at plasticity index can be 6 maximum, but in this example that we are dealing with, it has a plasticity index of 11. So it means this condition is not satisfied. So we go to the next, A1B. Remember, A1B has the same condition here for plasticity index. So that plasticity index condition is also not conforming with this A1B. So we are going to go to next. So here this says NP. NP means non-plastic. What is non-plastic? Means we cannot perform the liquid limit test, plastic limit test. But here we have got the values of liquid limit and plastic limit. It means this is a soil where we can do this test. So this is not A3. So we are going to move ahead. Now here it says number 200 is maximum 35%, and remember there is no requirement here, so no need to look at. So maximum is 35%, in this example it is 8, which is less than 35. It's okay. Liquid limit 40 maximum. So remember, our value is 42, 40 maximum. It is not satisfying. So once there is one cross, just go to the next. No need to check another. Okay, the 35 maximum is okay. 41 minimum means it can be 41, 42, 43 and above. Minimum is 41. It cannot be less than 41. So that our value is 42. It's okay. Next, it says 10 maximum, but our PI is 11, so this is not satisfied. Let's go to the next. 35 maximum, it's okay. 40 maximum, no, because the value is 42. Next, 35, 41, it's okay, and this is 11 minimum, so our value is 11. So now you see all the cases are now, all the conditions are satisfied. So the soil here is A27. So this soil is A27, and if you calculate the group index, definitely the group index is going to be 0. Okay, so, and remember this is A27, and we have seen earlier that if it is A27 or A26, we are going to use only the second part for the group index calculations. So let's look at group index. The group index is going to be equal to 0.01 P200 minus 15 PI minus 10. So let's put here 0.01 P200 is 8 minus 15, and this is 11 minus 10. And remember 8 is less than 15, so it is going to give us a negative answer, so it comes out to be minus 0.07. If it is negative, we are going to make it 0. See, so this classification is A27 with group index of 0. And if you see the previous lecture, the same soil we did classification in unified. So in unified it was SWSN, if you remember. So it was well graded sand with silt and gravel. So if we are dealing with the unified classification, it is SWSN. But if we are dealing with AASHTO, the same soil is A27 with group index 0. Okay, next is example number 2, and here in this example we are going to do the classification for this soil B. So this soil B, this soil only. And if you go back to your previous lecture, this was example 4 in the lecture of unified classification. Okay, so you can check what was that. It was actually, I think it was sand. Okay, now we have to look at first, whenever we are going to do the AASHTO classification, the first step is to look at what is the passing number 200. So here is number 200. So if I go down, so you see it is 0. So passing number 200 is equal to 0, which is less than 35. So this is a granular soil. Okay, and this soil, remember passing number 200 is 0. It is less than 5%. So when it is less than 5%, we cannot do liquid limit plastic limit test. So it's a non-plastic soil. So it means no liquid limit plastic limit values. It's an NP soil. Okay, so what we need from here is, if you look at this granular material table, let me just copy that table from here. And we are going to clear all that here. So what we need is passing number 10, number 40 and number 200. So let's go back and find out P10 and P40 and P200. P200 is 0. Now what is P10? Okay, number 10 sieve is 2 millimeter. So where is 2 millimeter? So let me first find where is 2 millimeter. This is 1, this is 2. So this line is actually number 10 sieve. We also need number 40. It's not written here. So number 40 sieve is 0.425. Now where is 0.4? This is 0.1, 0.2, 0.3, 0.4. This is 0.5. So it is in between. So this line is actually, I will take this 0.4 because there's not much difference between 0.4 and 0.425, 2, 3, 4. So this is 0.1, 2, 3, 4. So that is number 40. Number 40. So let's start with number 10. So we are going to draw the line, and when we reach this S-shaped curve, from there we are going to draw a horizontal line. So this value comes as let's say 42, 42, 43. Let me take it 42. And now let's look at the next 40 number C. So this is 40. Let me draw here the line. This is number 40. Okay, the line is not straight. Okay, so this is somewhere here. So from there I can go like this. So it's something in between 10 and 20. So it's maybe I can take it 15%. So when you are going to do this, use the scale so that you get accurate values. Okay, now we have got P10, P40, P200, and we know it's non-plastic soil. It's time to classify using the table. So P10 is okay, what is the value? 42, 15 and 0. 42, 15, 0, and it is NP, no values. Okay, so let's start with the first number 10, 50 maximum. 42, it's less than 50, it's okay. Okay, number 40, 30 maximum. What is our value? 15, which is less than 30. Number 200 is 15 maximum. In our case is 0. And here you see it says plastic limit can go up to maximum 6. So it could be non-plastic and up to maximum 6. So in our case we have no value. So what we are going to do, we are going to select this soil. So this is going to be our soil A1A, and you are going to calculate the group index, and when you calculate group index you will see that it is going to be 0. You should try. So this soil B is A1A and with group index 0. A1A. Okay, and when we did this classification in unified classification system, it was SW. It was well graded sand with some gravel. Well graded sand with gravel. Check your notes of the previous lecture. Okay, next we are going to take some soils from here. Here is an example. I took it from book. So we have 5 soils. So I'm going to do some classification, and you can try yourself the remaining. So here passing number 10, number 40, number 200, liquid limit, plasticity index, all are given in the form of table, so you don't have to go to that gradation curve. So you will just pick the values from here and we are going to classify. So let's do the next example, and I'm going to start with this soil D. So this is going to be our example number 3. This is going to be our example number 3. So let's take this soil D, example number 3. So passing 10, 40 and 200 is 100, 184. So this is 100, 184, and liquid limit plasticity index is 60 and 27. So this is 60 and 27. 60 and 27. So let's start. Now, because the in this case passing number 200 is more than 35, this is going to be fine grained soil, or I can call it silt clay. So we are going to now use the second table. This is the second table, this one. Okay, let's start from here. So what we need here is number 10, number 40, number 200, liquid limit and plasticity index. Let's start from the leftmost column. Passing number 200 is minimum 36. It means it could be 36 and above. Our value is 84, so it's okay. Liquid limit is 40 maximum. It can be maximum 40, but what is our value? 60, not matching. So just move on to the next. This is matching. 41 minimum means it could be 41 and above. It's okay. Now the plasticity index is 10 maximum, means it cannot be more than 10, but in this example it is 27, so this is not matching. Go to the next. This is okay. 40 maximum is not okay. Go to the next. And then here we see it is 36 minimum, 41 minimum, our value is 60, and 11 minimum. Minimum value is 11. It could be more than 11, so our value is 27. It is okay. So here is some mistake in the printing. So actually this A7 is going to be it's not correct here. It is going to be A7 here, and this is also not correct. So this is A7 5, and over here there is small a written, and then there is A7 6, and there is small b written. A7 5 and A7 6. There are further two divisions in A7 group. So in your notes, please correct this. This is A7 and nothing is here. Nothing is here. Okay. So what is this A and B? For this A and B, you have to look at here. So this says if it is A75, these are the conditions. Now let's look at the condition. What is the plasticity index? The plasticity index is 27. And what is liquid limit minus 30? So liquid limit minus 30, 60 minus 30, which is equal to 30. So you see, we see that plasticity index is 27, which is less than liquid limit minus 30, which is 30. So 27 is less than 30. So it means plasticity index is less than liquid limit minus 30. So when plasticity index is less than liquid limit minus 30, then the group is going to be A75. So you see, all the conditions are satisfied, but our soil is going to be A75. Why? Because of this condition. Because of this condition. So the soil is A75. Now we have to calculate the group index. So if you remember the formula for group index, it is P200 minus 35. See from your notes, 0.2 plus 0.005, liquid limit minus 40, plus 0.01 passing 200 minus 15 times plasticity index minus 10. So just put the values. Passing 200 is 84 minus 35. This is 0.2 plus 0.005. Liquid limit is 60. So it is 60 minus 40 plus 0.01. 84 minus 15, and plasticity index was 27 minus 10. Okay, simplify this. It will come as 26.43. Now what we are going to do, we are going to round off to a digit, or I can call it integer, whole number. So because it is less than 0.5, so it is going to be 26. So what is this classification? It is A75 with group index 26. So this is that classification. So what you can do is you can try yourself all other cases. So let me just check it here. So this is A75 with group index 26. Let us now do this next case, which is soil number this is soil 2. So I will do this as an example number 4. Okay, so remember the values. This is 100, 100, 70, 40 and 10. So this is our example number 4. So this is 100, 100, 70, 40, 10. So this is the same data that we got from the table soil E that I call example number 4. So here we see that passing number 200 is more than 35. So it's a sandy silty clay material. So we are going to use this table. So let us start. The first number 200, see if passing is 36, minimum means 36 and above. It's okay because in the example it is 70. Next is plasticity index 40 maximum, not liquid limit 40 maximum. Our value is 40, and pi is 10 maximum, and our value is 10. So all the conditions are satisfying in this very first case. So the soil is A4. So this is going to be A4. Now you have to calculate what is group index. So do it yourself. I'll just go back and see what is this soil. So this is A4, and when you are going to calculate, group index is going to be 0. So you should try also this soil F. This is also A4 with group index 0, and you should try the soil G. This is A3 with the group index 0. Okay, try it yourself. Now there are some other examples also. So here is a page. Please do this as a practice. There are 4 soils. You can read the passing number 10, 40, 200 from this graph, and the liquid limit and plasticity index values are given. And for some more practice, there are some more questions. So here I have both for unified classification and for AASHTO, and the classification is already there. So please check if your answers are matching or not. So this is going to give you a very good chance of doing practice. So with this we come to the end of this chapter. So we have discussed both unified classification and AASHTO classification. Okay, so please practice these questions, and I'm going to give you one assignment, and I am going to give you some more questions for your understanding. Thank you so much and have a great day.